my name is Albertina and I'm here from Cornerstone Laser. Today I'm going to help you out in the first of a multi-part series in enclosure design. So the intent is that we're going to create a series of episodes with the intention of helping beginners getting started into lasers, particularly laser diodes. And just a bit about me. I'm a mechanical engineer. I do have a day job, but I really enjoy lasers. I've been working on them for multiple years now. And I've built my own lasers, multiple iterations of it. I currently have a laser diode, which is a commercial version, which I currently use. We have our own small business called Cornerstone Laser, and I know that there's a lot of people out there that really want to get started in lasers. There's a lot to learn, and I've gone through it right through the stages, building my own laser, helping out with the programming or developing the programming, and eventually using it to create a systemized model for eventually building a business out of that. So I know that there's a lot of people that are struggling. You don't really know where to start. There's so many different types of lasers available on the market these days, and the aim of this series is really to help you get started, what to look for in the beginning, a couple of things that trip me up, and maybe optimization. So today's episode in particular is enclosure design. So that's the enclosure of my lasers, the one that you see next to me on the right hand side. And so let's get started. Now, as you may be aware, there are a large amount of different types of lasers types that are on the market today. The first probably, or the most notable, is diode lasers. It's typically the laser that would be in a CD reader or an old CD player. That's been, the power's been bumped up to a place where it can actually engrave and cut and burn. The next step up is typically a CO2 laser, so that's much more powerful. Got a CO2 tube that's typically water cooled. It typically comes with its own enclosure, but it's often an order of magnitude more expensive. And more recently, you get fiber lasers. Now, fiber lasers again is significantly more expensive than that, but the range of cutting is significantly broader. So the biggest difference between them is obviously the operating principles, how they work. So there's not an extensive discussion how they work. There's different resources on that. I might actually do a video on that separately, but there's a significant difference in cost. For instance, the laser, which I'll show you in a second, my one is a Neji Master 2S. That's noted as a 30 watt laser module, but it's not 30 watt comparable to a CO2 laser. When you compare a CO2 laser, which is typically your hobby type lasers like a Glowforge or OhmTech or something similar, those would typically be in your 50 to 60 to 70 watt ranges. Whereas the diode lasers, although it indicates it's a 30 watt module, the equivalent when you compare it to a CO2 laser is only about 7.5 watts. Now the output that you can get out of a laser diode is actually limited, and the most powerful ones that you can get these days actually combine multiple laser diodes in the same unit. And again, that's sort of out of the scope of this discussion. It can be a little bit complicated, but just to give you an indication, my laser that I purchased, the Neji Master 2S, that was about $500. I'm working in New Zealand dollars because we are based in New Zealand. Your cheapest desktop laser, above that, your CO2 laser would be an order of magnitude greater. So that you're looking at about $5,000 to $7,000 plus, depending on the type of desktop laser you go to. And then when you go to fiber lasers, again, you're talking at about $15,000 plus. So it's really a huge range of costs. So really, when you're a beginner and you want to start out and just try and figure out the laser, sort of environment, you might want to start with a diode laser because that's more budget friendly, and then as you get more proficient with it, you might go to a desktop CO2 laser, or if you really want to get started and you want to get cutting fairly quickly, then you would want to go to a CO2 laser. So the biggest differences between, for instance, the diode laser and the CO2 laser is the power and obviously the cost. But the power on the lower end of the diode lasers is really limiting in terms of cutting materials. So it's very difficult to get the power up so that you can actually cut through wood, cut through leather, but it does engrave really, really well, and the quality that you get from engravings is actually superb. So if you can get templates that are pre-cut or cut for you, or cut on a more powerful laser that you just engrave like we do in our business, and it's actually a really great tool. It's super accurate, and as long as you understand how it works, and it can give you great results. Some of the results we have is something like this. So this is typically a blueprint design that I got off Etsy, and it came out really nicely. These we do actually sell in our shop, and I really love Star Wars. I love Marvel. I love Batman and all sorts of things, and to be able to engrave this with a fairly cheap machine is actually an amazing way to use these things. Now you might want to ask yourself, why do I need an enclosure for my laser? Well, if you've done any sort of research on specifically diode lasers, you'll realize that it is a class 4 laser product, which means that the laser has been made so powerful that it's really damaging to your eyesight. In fact, the damage it makes is permanent, and it could literally blind you in a matter of a split second. Faster than you could blink your eye. Even a reflection of a laser beam at full power could actually make you blind or significantly damage your eyesight, and that would be permanent. And so I really want to encourage everybody to take the right precautions. Any commercial laser that you buy should come with the appropriate goggles. And I really want to encourage you, even at low power, even if you're setting up the machine initially, just wear your glasses. It's not worth the risk. I've actually gone to the trouble of purchasing quite an expensive pair of glasses just to protect my eyesight, because obviously that is irreplaceable. Now, when I first got started in lasers, the first one that I actually built, I bought the components separately and I actually put it together myself, and at the time I didn't feel that the enclosure was appropriate because it would just take too long. But the reason you would have an enclosure firstly is obviously to prevent the scattered beams. So if you want to work in an environment, currently we do this in a workshop or a garage, you'd want to still be able to access the garage. You want your kids or your family to still be able to access it safely without the risk of being exposed to laser beams. Or even reflections of the laser. The second one is smoke control. So typically when you're burning wood or any materials, there's a lot of smoke that's generated, and with an enclosure it actually allows you to get rid of that smoke in a contained way. What I did initially with my first one, as I mentioned, I didn't actually have an enclosure, so when I stepped out of the workshop or the garage, I actually locked the door. I closed all the windows to ensure that no one would go there accidentally or walk in there without having the appropriate eye protection. Secondly, if we had a cat at the time, if we left the windows open, she was prone to jump through the window. Obviously laser beams and cats is probably not a good combination, and the last thing you want to do is blind your pets or actually injure them, or your children walking into the room where they don't know actually the risks that they're being exposed to. And so that's why it really makes sense to build the laser enclosure. It does take a bit of time. That's really what this video is about. So yeah, let's crack in and we can have a look at it. Now this is my laser. So as I mentioned, it's a Neji Master 2S. So this is a 2-axis laser. So most lasers are actually 2 axes. So it's got an X and a Y direction, and you can see it's cantilevered, so it doesn't have support on both sides. It's only got support on one side, and you'll see on the left-hand side of the gantry over here is the stepper motors, and that sort of balances it out. And I went to this design because it's actually more compact than a simply supported, which would be supported on both sides, and it gives you a fairly large working area. So the working area of this is about the size of an A3 piece of paper. You can see the enclosure that I've actually got here is made of MDF, so this is a 6mm MDF, and I've got holes on both sides over here to actually suck in air on the one side, and I've got an extraction fan. So this is a type of 220 volt CPU fan, which then has a ducted vent, a 4-inch ducted vent on the outside. Then I'm actually close to the window on the left hand side of this image, and then I can actually duct and vent the smoke out of the window. Other more fancier versions have like a filter that you can take it through, but typically most laser diode units don't really have that. Now this enclosure does work well. There's a couple of design considerations. I really wanted to make it simple. Obviously my laser cannot cut 6mm MDF, and therefore I had to go to a different supplier. So I actually did the design of the enclosure itself, and then I gave it to a laser cutting company, and they actually cut it for me. Now I wanted to go for a really simplistic design, as I mentioned, so I used an online box generator to actually generate this design. Obviously, what you'd want to do initially is take the outer dimensions of your laser unit, whatever they may be, and make sure that you give a generous amount on either side. As you can see over there, there's a lot of cables hanging over. As the laser gantry moves, the cables will move, and so we really wanted to make sure that you leave enough space in the height, but also on the left and the right, so that you don't make the box too small and you can't actually work in it. It's also beneficial. Obviously, I've got a lid, which I'll get to in a second. but you need to make sure that you really leave enough space that you can actually do the work. The box generator, I really wanted to go to this sort of slotted design, and the reason being we wanted to make it as light tight as possible. You don't want any of the light from the laser to escape, and that would allow you, while the laser is actually operating, is that you can work and move around in your workshop or garage with very, very low risk of actually being exposed to scattered or reflected beams. And I felt that this was the best way to actually allow it to lock properly, because it's a lot easier also to assemble the box if it's got these structures. There's a lot of great resources, online box generators that are free. You can basically literally input the dimensions of your box, tell it the width of the slots that you want, and then it will generate that in a two-dimensional format, and you can then give that to a company that can cut this for you really, really simply and cheaply. And I've actually put a link to the one that I used in the description below. Now you'll notice as well that the base, I tried to make everything out of 6mm MDF except the lid, which I'll get to in a second, but the base is also made of 6mm MDF, but that's not actually got the same slotted design. And the reason for that is I didn't want the base to slot, so that I could leave some access on either side. If I just move the camera a little bit to the left over here, you can see there's a little bit of a gap in the base, and it's got that gap all round, and that would allow me to attach things to it, and would just give me a bit more space on the bottom to actually attach it. Now, the way that I did that in the design, in the box design, was to flip it over. So there's an option in this particular box design to say that the lid, or what would be the top, is not slotted, and that for the reason is to put a lid on top of it. Now, what I actually did was I effectively flipped it over. So what would be the top in the design is actually the base of mine. And the reason I did that again is just to facilitate the assembly. And then what I did was I basically fitted the slots on either end, and then I used angle brackets to attach them to each other. And I put some black duct tape in the joints just to make sure that no reflective light does escape. Now the lid was interesting. So as I've mentioned, you do get obviously, depending on the spectrum of light that your laser is designed to, this is actually a blue laser. So if you understand light wavelengths, blue and green is on the one side of the light spectrum, and red and orange is on the other side of the spectrum. So if you want to block a blue laser, you typically get a red or an orange type of laser goggle. So this is a more expensive version. I think this is from a Dragon Laser or something. I bought it from the US, and it is like rated for this type of laser. And again, I did that just to protect my eyesight and make sure that there's no damage there. Now the cover that you see here is not actually rated to block any laser. Well, it's not rated to block this type of laser beam, but it is orange, and so therefore my expectation is that it does block most of it. So it's not to say that when the lid is closed, it will block all of the laser. You still, typically when I look at the laser even through the lid, I still put on my glasses, but it's the intention is that it blocks most of the laser light, so that even if the lid is closed, you can still work in the area as long as you don't look directly at the laser. And obviously the intention being that if this thing was running, I wouldn't have to open the lid all the time to see what was going on, and I could leave the lid closed. Now this in particular is only a 3mm, and it's a simple semi-transparent orange or red type of acrylic. And that's, again, that was the instruction to the company that I used to cut my enclosure. And that's simply just attached to the back there with two hinges, and then a simple knob is installed at the top. As you can see, it's also got the slotted design so that it fits in nice and neatly when it closes, and there's minimum light. Again, what I wanted to prevent was that this thing would just be flat, and when it actually sits on top, then it would warp because of the weight on the top, and then it would lead to a lot of light leakage, which would then render the enclosure null and void for practical purposes. So this actually works really well. It's simple to use. Just bear in mind that if you have a really wide or large enclosure, the weight of the lid is going to sag, and that might be a little bit of a concern if you have a really big enclosure. This one actually works pretty well. Something else that's really important is obviously the extraction of the smoke. Now, typically a rule of thumb is that you want to make your inlet, wherever you suck in the air, because you obviously need to replace the air that you're taking out, about 1.5 to 2 times the size of the orifice that you're extracting the air from. And that's just to make sure that you get sufficient airflow coming in and that you don't accelerate the flow. So if you know anything about fluid mechanics, if you accelerate the flow too quickly through a converging nozzle, then the velocity will be relatively high. And although that's probably not necessarily an issue for you, it might create a lot of noise. You know, if you've got a high velocity, if your inlets are too small, it might create noise, but probably more importantly, if you had something that was light that you were cutting, say for instance paper, the high speed of the air that was coming in might actually disrupt your workpiece while you're working. So you really want to make sure that the hole size of your inlets is actually well sized to your outlet. So as I mentioned, the outlet for this one is about a 4-inch, so that's about 100 millimeters in diameter, and these two elbows are actually 90 millimeters each, if memory serves, 90 or 80 millimeters each, so it actually works really well. The reason they're actually curved like this is obviously you don't just want to cut a hole in the side, because that effectively negates the first priority of having this enclosure, and that is really to ensure that light doesn't escape. So if you just cut a hole in this thing, you can imagine the amount of light that would escape. And so I really considered what the simplest way would be to mitigate that. Now, a couple of things that I did consider was cutting a hole in it and then putting a larger plate, for instance, on the outside, and that would mean that the light would basically hit the plate, but that you'd have a gap between the plate. What I mean by plate, it would be another piece of MDF that you just offset so that air could still come in, but the light would be blocked. But that wouldn't really work if it was on the outside, to be honest, because a lot of the light would still scatter out. It would reflect on your plate, for instance, and go out. And if you looked at it at the angle of the gap, you would still be able to see much of the light. So that wouldn't really help. The other alternative was putting one on the inside, but then you effectively reduce the size of your enclosure, and you need to make the enclosure bigger on the one side to account for that, and it just didn't seem like the best approach because it would create a lot of obstruction inside. And again, I think you'd sit with the same issue with light reflecting and still being able to come out. And so I actually found this on Thingiverse. At the time, I had a 3D printer, and so printing something in 3 dimensions wasn't really an issue. This obviously is a flanged 90-degree elbow, and I literally downloaded it off Thingiverse and printed 2 versions of them. You can see that the one is turned down and one's turned to the left. I think the reason for that particular one is to just leave some space for the extensions. But what it effectively does is it allows air to come in, and it effectively doesn't allow the light to escape. So the one on the back end, some of the light does actually reflect on the back wall when it's working, but the amount is actually very limited. So it works pretty well. I must say it is the simplest approach that I have found. I mean, if you guys think that there's something better, I would appreciate if you can leave a comment below, but this does seem to work really, really well. And if you've got access to a 3D printer, you've got a buddy that has a 3D printer, it's really super simple to print, and it works really well. Getting to the outlet, again, that's just a 3D printed component, and I downloaded that off Thingiverse. I've left a link or the file in the description if you wanted to print that, and it works really well. So I had this is just a normal 220 volt AC extractor fan that I had left over from another project, but I'm sure if you wanted to buy that, you could probably get it relatively cheap. It's got a really nice throughput. It's pretty much got a silent fan, and it extracts really, really well. It's really nice and compact. It doesn't take a whole lot of space, and it works really well with this extractor. And I just got a simple duct that you'd use in the roof, and I can basically open up the window and extract it right out. And this really, really works very well, this combination. And then all I've done is I've routed the cord for that into a plug, and whenever I need to turn it on, I just switch it on and off it goes. It's pretty quiet and it runs really well. There are a couple of design considerations and things that I do need to make better, which I just wanted to notify you of. So basically, once I had downloaded the box design, I opened up a Lightburn software, or you could use any sort of CAD software, maybe even Inkscape would work. And I didn't want to have to drill the holes or make the holes for the inlet and the outlet after that already cut the board. So if you're going to get it laser cut, you might as well cut the holes in the right place that you want them. Now, one thing I didn't do was, because I mentioned earlier that in reality, the bottom is actually the top in the design. And so the intention was that I wanted to put the holes at the top on both sides, because then, the smoke will rise and you really want to suck the air across your workspace, ideally at the top where it will rise and also be out of the way. But because I had sort of flipped it over, I actually put it at the bottom in the design. It's not the end of the world. It still seems to work, but just be mindful of that when you actually do that. And so it would be good if you could put that already in your design at the right place. So when you come to assemble it, everything's already there. It could be easy enough. Another thing to consider is I made the base the same thickness as the rest, because I didn't really want to go to different material. But 6mm is not really thick enough. If you try and put a screw or something through the bottom to really try and hold this thing down, then 6mm is not thick enough. I would go to at least a 10 or 12mm, maybe a 14mm thick base. And that will just give you enough stiffness so that it doesn't bend or warp when you're trying to carry it around. It also gives you enough thickness that you can actually drill screws into it and whatever you want to attach on the bottom. That was a real struggle that I had. The other thing I've done is I've had some LED lighting that's left over from another project, and I've installed that. That works really well. It's super cheap. You can get it from AliExpress for no money at all, and it's just powered by a USB charger. So I got an old cell phone charger, and I just plugged them in, and off we go. It really works very, very well. Another thing you would really need to consider is where your enclosure would stand in relation to the extraction. So obviously you'd want to take it out of a window, and you don't necessarily really want to run significant lengths of ducting unless you have no other choice and you need to run significant lengths of ducting. But in my case, I was quite fortunate that the extraction area is very close to the window. But just think about that when you're actually doing your design to know which side it goes on. And obviously you would want to be able to suck in air from the one side and take it across your workpiece to the other side. You obviously don't want to put your inlets over here, for instance, and short circuit the way to the outlet where it doesn't actually extract the smoke. So that seems pretty obvious, but just make sure that you do take that into account when you do your design. Probably one final consideration is you need to think about how you're going to locate your laser in the same position. Now, if you're like me, again, this laser diode isn't powerful enough to really cut through many materials, so it engraves really well. But if you want to do like cutting boards or things like that, you really need to be able to replicate it and position the workpiece in relation to your laser consistently each and every time. Now you'll see that I've lasered a grid pattern on the base here, which I'll go through in another video as to the reason for that. But what I really wanted to show you as part of an enclosure design again is to locate your laser. So what I did was, because of the thickness of the base, which I indicated earlier, it wasn't really thick enough to be able to put screws in here. But this laser base did come with a place where you could locate the foot pieces on the four ends. And so what I did was I drilled a hole that didn't go through the whole base, but I just used basically a bookshelf holder to lock it in place. That's not the best approach, but it does work reasonably well. It works well enough to actually keep my laser in a consistent position in relation to the grid at all times. But that's something that you certainly need to consider. The last thing you want is bump your laser and it moves out of alignment, especially when you've actually got a grid, and then you struggle to get it back, and that messes up your workpieces because it's in a different position in relation to your workpiece. Alright, and that brings us to the end of this episode. I really hope that it was helpful for you in your journey. It's a lot to say about a simple enclosure, but I really do feel it's important, and it really gives me a lot of flexibility to allow me to do work in the enclosure, vent the smoke out, and I've got no risk really of somebody being inadvertently exposed to laser reflections or laser beams. I really hope that you enjoyed this video, and I would appreciate if you like and subscribe, and that would help me to make more videos like this in the future. If you wanted to have or understand a particular topic in future, I will be doing a couple of them. If you want something specific, please let me know in the comments, and I'll try and address that in the future. Thank you.